Okay, cool. Um, okay, I'm gonna get started. Grab a seat. Hopefully, try and see the screen. There's gonna be a bunch of screen going on. There's gonna be a decent amount of furious alt tabbing, reload, spamming, git branch changing, etc. throughout the presentation. So it might not be the smoothest, but some of that's kind of the nature of what I'm gonna be demoing here a bit. So this talk, first of all, who I am. So my name's Zittlau. I work at Jobber. I've got various online presences, which you can find under my name, or if you're curious about Jobber, you can check us out at getjobber.com. And my talk is on trying to offline the online, and more specifically on something called service workers, which you may or may not have heard much about. So I'll just kind of get into it. So what we're going to cover today, so what service workers are, so I'll explain that a little bit. Service workers for static content, so if you have like a website or something like that, what service workers might look like for that. Service workers for dynamic content, so if you're doing something more Ajax-y, web app based, what it could kind of look like for that. And then we'll see how we're doing for time. If we have time, I'll talk about some of the challenges. If I don't have time, you'll leave here just thinking that service workers are amazing. So we'll see how that goes. So first of all, what are service workers? Basically, one of the most straightforward descriptions is it's the replacement for app cache. So you might have heard this thing called app cache before. So here's a description of app cache. HTML5 provides an application caching mechanism that lets web-based applications run offline. Developers can use the application cache interface to specify resources the browser should cache and make available to offline users. Applications that are cached load and work correctly even if users click the refresh button when they are offline. So this description almost would be exactly the description for service workers as well, but it's not. It's a description for this deprecated tech called app cache, which now in the HTML specs, the living HTML standard, what they use to describe app cache is this feature is in the process of being removed. Using any of the offline web application features this time is highly discouraged, referring to app cache. Use service workers instead. So again, service workers are pretty much like a direct replacement for what we were doing previously with something called an app cache. So again, app cache was just this attempt to allow applications to work offline. And the way it was supposed to work, and barely anyone ever actually ended up using, was this idea that you could just add this attribute to your HTML, where you go HTML manifest equals, and this place is clock.appcache. And then you'd have this in this app cache file, that's what this would be. You'd have this cache and you'd list names of files. There's a few other sections that you could have in that file. And basically specify that I want the browser to grab these files and keep them offline, so if someone tries to load the page, they'd have those things available. To do the exact same thing in service workers requires a bunch more code. So first of all, you have to register a service worker. So this is kind of similar to what the purpose of this manifest equals clock.appcache, but I do it in JavaScript. I go navigator, so this would be like in my index page, whichever page. I'd have JavaScript that goes navigator.serviceworker.register, and I give it the name of a file. So here I'm just calling it serviceworker.js. It could be called whatever you want to be called. And then the rest of this would be in that service worker file. So I have to listen to this install event, then I have to do this event.waitUntil. So event.waitUntil, you can see that's what I'm passed in here is this event. WaitUntil tells the browser that like I'm going to give you a promise. I'm not done installing until that promise resolves. Then inside of that, I do this caches.open and I give it a name. This again can be anything. This is going to return a promise to WaitUntil. Actually in there, sorry, it's going to resolve, and then in here I'm going to do this cache.addAll, which I'm passing in a list of the files. So basically through all these like various nested promises, at the bottom of this I'm doing this cache.addAll. And what I'm telling the browser is the same thing. I'm telling the browser, go fetch these resources, the resource at slash, the resource at app.js, and the resource at clock.png, grab those and store them. So again, basically exactly the same idea of what was going on here with this cache manifest. So that's what's happening when this service worker file loads. And then I have to now tell it what to do when it tries to fetch files. So once a service worker has been loaded, I add another event listener. So before we did install, this one is fetch. And what's really interesting about this is every network request that happens on my page after the service worker has loaded, runs through this function. So literally like everything, like whether it's loading CSS, JavaScript, HTML docs, Ajax things, everything runs through this fetch function, and then I can decide what I want to do in here. If I don't do anything, it doesn't do anything, and it'll just behave like it normally would. It would go to the network. But then similar to here where I could have event.waitUntil, if I go event.respond with, then I can do something. And this event has the request that is trying to send out there, and I can pass that into my caches. So before these caches that I loaded these files into, and this does this match. So basically it looks and says, do I have that thing, that whatever is trying to fetch? And if it does, it returns that. So basically this intercepts a request that would otherwise have been going out to the network, looks into these caches that I've loaded, and then returns the file. So with what I have here, registering the service worker, this install step that loads these files into the cache, and then this fetch is going to do basically the same thing that we would have done with the app cache before. So I'm going to do a demo here. I have it set up, so it's a basic Vue app, so Vue.js is written in that, and it's got an API. Really straightforward. It's a world clock. So I've got these 4 different locales, and then for each of these it does an Ajax call to hidden API to say what is the time in each of those locales, and it fills it into these boxes. My server is just running here. If I kill this and go and reload, this isn't using a service worker yet. This is just the basic app. As we all would expect, we see this page that we're probably all far too familiar with. But if I go here, and if I remember my branch name, base page service worker, let's just do this. Good, check out base page. So this is basically what I showed you there. Its actual service worker has a little bit more boilerplate in it. But basically the same thing that I was showing you there. So now if we go back into here, back into here, and I load this, if we go into our Chrome DevTools, we can actually go here and see service workers, and we can see that the service worker has been loaded. So now what's going to happen when I go and I kill my server, and we go back into Chrome and I reload this, the page loads, which is really cool. But in this case, based on what I showed you there, the only things that has cached are those things that I told it to cache. So in here I told it that I want to cache the page, I wanted to cache my JavaScript, and I wanted to cache this clock file. So that's all we got. And you can see here that these API requests to go get those times, nothing came through there. It didn't have those cached at all. So in this case, again, we cached some static content, which was like kind of the base of this app. So that in itself is really interesting. It can be useful. Again, it doesn't do a ton more of what the app cache did before, but there's certain use cases where that's really useful. So for example, documentation sites. So Angular's documentation site runs service workers in it. So if you're on Angular's documentation site and you go view some of these pages and you go hop on a plane, you can hit reload and still get those pages as long as you viewed that page. I've actually used that. It's pretty useful. Someone was telling me that they use it for a conference schedule, which is a great application. So if you're at a conference, you go to their website, you can get the conference schedule. For some reason you lose data, the network at a conference is shit, something like that. You can still access and view that schedule because this is static content. A blog also, even though there's less clear applications for me of why you'd want to be viewing that blog offline, but a blog with static content, you could do the same type of thing, have the service worker file that just specifies those pages, and then someone can continue to view that when they're offline. But again, static content worked with app cache. App cache basically gave us that, but we want more power. So this is why we're here. This is why there is this concept of service workers, so we can have more power than what we got with app cache. So where things start to get really interesting is when we start dealing with dynamic content. So this is taking what I had before in the fetch function. So before we were just looking in our cache to see if we had something and returning it. So now what I've added here is the same thing. So we look in our cache and we see if it hit. So if there was response, return that. But now what we're going to do is if the cache misses, we're actually going to go and do a fetch. So this is just the HTML fetch API. We're going to give it that request, and then when we get that response back, we're going to open up our caches again, and we're going to save that response that we got into our cache, and then we're going to return it back. Now, there's some boilerplate going on here with these clone calls. Don't worry about that too much. Basically, it's because the response is a stream. Once you consume a stream once, you can't consume it twice. So if you put it in our cache and we tried to feed it back to the browser, it would barf because it had already consumed that stream. So by modifying what we're doing in that fetch block, now we can, whenever it tries to fetch something, if it doesn't have that, is going to add it to that cache. So like in this example, those API calls, it didn't have those in the cache, but now when it does them, it can try and do that. So I'm going to do a demo of that. So I'm going to have to get this running. First of all, I'm going to show you just another thing in the dev tools here, where again we can view our service workers. We can also go in here and see cache storage, and we can actually see what was stored. So on this first version, just like we expected, the only things we see in here are the things I told, the slash, app.js, clock.png. Okay, now I need to go here. We're going to change our branch. Request. Great. I'm going to restart our server. And then I'm going to go here. I'm going to kill this. I'm going to do this. I'm going to do this. All right, great. Okay, so now I have this page. I'm just going to reload it because I like reloading. Okay, great. So in theory, I should be able to do this magic trick now where I'm going to kill my server. I'm going to go back into here. I'm going to reload it. And not only did I get that page, but I also got these times. And if we go in here and we look in our cache, sure enough, these time zone requests to my server, and we can actually see the response values, are sitting here in this cache. So when the network asks for it, even though there's no backend server and I can reload again, it's still getting a response to these requests. So that's pretty cool. So that's where like service workers really start to get interesting, is starting to deal with some of this dynamic content. Cool. But there's a problem with this demo. Let's go back to that. Do you see those times changing? No. But if we look here, I actually have polling built into this. So if we wait, there we go. It just fetched them again. But it's continuing to get that same value. So in this case, my server is offline. But even if I bring my server back online, we're going to be sitting here staring at those same times. And the reason for that is cache invalidation, right? So we've probably all heard this classic quote: there are two hard problems in computer science, cache invalidation, naming things in off by one errors. So somehow we have to deal with this cache invalidation problem. And service workers, for all their glory in giving us control, they give us all the control. So they don't do any cache invalidation stuff for us. So you can easily end up in this mode where, like, even in a documentation case, you like publish that documentation once, someone caches it, and now they think that Angular hasn't been updated in 2 years because of their service worker cache. So it does allow us to go in. So we can again open up our caches, and we can do this cache delete and give it a URL. But how would you know which URL to delete? So the service worker is its own kind of JavaScript file and it's doing these things. And then we have our app, which is doing its things. But often in terms of cache invalidation, you're going to want to pass some kind of knowledge from your app to the service worker to tell it what to do. If the service worker had to just work all on its own, it often wouldn't know the right times. You know, did someone just do a pull refresh and it should nuke its cache and wait for something? So there is a mechanism. So we can do this navigator.serviceworker.controller. So in the page, if we call this, this will return the currently registered service worker, and then I can post a message to it. So here I'm showing that I'm going to send it a URL for the Edmonton time zone. So this is what would be in my app code, so my view app. And then in the service worker, it's going to add another event listener for a message, and it's going to receive that And like here, I'm just showing it logging what it would get. But we can do something with that. So API request, one-way communication, great. Do I have a typo in there? Good, check out API request, service, worker. All right, great. So in here, I can show you my implementation of that. So just like I said, it as an event listener to message, and I get an event, I have this data payload event.data.url, and that's going to tell me that I want to delete whichever URL I've passed to it. And in my view here, basically I've set up a call. So if this event fires, is going to, just like that code that I showed, navigator, service worker, controller, post message with that URL. So if we go to my app, nuke that, do this, great. What I should be able to do now is click on one of these. So we're going to click on Edmonton, and it should send that message to the cache, tell it to delete that thing from the cache. So the next time it pulls, it should get a new value. And for some reason, oh yeah, I didn't reload. I'll come back to that later if we have time. So now these should not be, there we go. These are now stuck. And if I click on this, we can see logging, telling that basically the messages got passed around correctly, and then we saw Edmonton's time. So here I'll go click on LA. So that's going to remove LA from the cache, and the next time it pulls is going to get a new value. So you know, that's kind of neat, and it's definitely an improvement. I now have a way where from my app I can tell this service worker to go and validate one part of this cache. But of course there's a lot of lag there. So like I was clicking, but there's no way for the app to know when the service worker had finished, if it finished successfully. So I'm still just doing this timeout, wait 5 seconds thing. What would be really nice is if the service worker could send back to the app and say, okay, I'm done now. I finished deleting that. Go do what you want to do. And there is a mechanism for that, but it gets complicated. And the reason it gets complicated is because a service worker is a one-to-many. So the service worker registers itself for a certain origin, so for a certain domain. And then if I open up multiple tabs, they are all using that same service worker. So here, I can go look at that service worker. And I can see, well, it's number 0. And actually here you can see as well, where it lists clients, these are all my different tabs. So all these tabs are subscribed to that same service worker. So if that service worker got a message from one of these tabs, how does it know which tab that came from and which one it needs to respond back to? So what we need to do is use something called a message channel, which is an object that HTML gives us, where basically we're going to give one port of this message channel to my client, to the tab. I'm going to give another one to the service worker, and then they can use that as basically a stream to talk back and forth to each other. So a bit more boilerplate in here, just creating a message channel, and this would all be in the app code. So I create a message channel, and then I set up a handler. So this is basically on the app side where I'm going to get a callback. This is where the service worker will be pinging me back, and I'm saying what I want it to do. And then again, I post a message to the service worker just like I did before, but now I pass this additional argument, which is telling it which port I want it to communicate back to me on. And then the service worker, just like before, I had an event listener on message. And then on this event now, there's going to be event.ports. So that's the port that I passed, automatically gets put into this ports property on the object, and I can send a message back on that port. So here's just an example of what this would look like to delete something. And this is basically the code that I have in the app. So it's going to get a message just like before with the URL, and it's just going to delete it just like before. But then what we've done is we've chained an additional promise handler on here, where when it's done deleting that thing, it's going to post a message back to the client saying, I've deleted that successfully. I'm going to try copy and pasting. Let's see here. Cool. Okay, and I'm gonna do that. I'm gonna do this. I'm gonna do this. I'm gonna do this. I'm gonna do this. Cool. Okay, so now in theory, if everything's working right, I should be able to click on one of these, and almost right away we should see a new time show up. Cool, so I clicked on that. Basically what happened, that sent a message to the service worker saying delete the cache for Edmonton, and it sent a message back saying, okay, I'm done, you can send another request. It sent the request and I got that updated value. So similarly, I can go and click on any one of these and I get a value updated very quickly. So that's kind of like just a quick little insight into the features that are there to allow you to kind of take ownership of this cache control from your app, but also some of the complexity that very quickly starts to emerge about how you actually want to handle that. So again, like for those static cases, like a conference schedule, it can give you a lot of power really quickly. If you want to bring it in, like even for a basic web app like this one I did here, all of a sudden a lot of this like complexity starts to emerge very quickly. So either you're probably going to be wanting with a tool set which manages some of this stuff for you, or like figure out your own paradigms as opposed to dealing with things in a one-off manner. Okay, so that's basically my time. So I guess we're going to go with the world where you think that everything with server workers is all sunshine and roses. Even though you might have noticed me doing a lot of incognito and refresh spamming and restarting things, which is also just a quick hint into some of the challenges of doing dev against service workers when you start throwing all these different types of cache at things, and like, am I actually running the version of code that I think I'm running? So I'm going to pass this. My slides are online. I think Mark has the link. So you can go check out this section of the talk if you're interested. So we just covered the first three of these, what service workers are, using it for static content, using it for dynamic content. The one slide I actually am just going to really quickly show is this one, browser support. This is important. The browser support is not there yet. This is coming. Pretty much all the major browsers, so Edge and Safari, are in development or in their previews, but they are not in the release versions of those browsers yet. This is me, Ben Zittlau. Feel free to connect with me. I'll be hanging out afterwards if you have any questions. Find me online. And then again in here, I have links out to some great resources. Jake Archibald has some excellent resources where he talks about this stuff. It's very readable. So there's some great stuff out there if you want to learn more.
Ben, question. I assume you've used service workers with Jobber?
No.
No?
No.
Have you used them in any production app yet?
I have not used them in any production app. I'm very interested in them. Actually, in applications at Jobber as well, there are definitely challenges where users lose data or even we're down, and there's very interesting things that you could do with service workers to proactively fetch some type of fallback application or some type of like fallback content and have that available to them. But with the browser support where it is right now, basically you're doing that for Google, for Chrome. So no, I haven't used them in any production app yet, and I'd be very hesitant to until some more of that browser support is in place.
So what would you say is like the main pros and cons of using service workers versus designing your application to use local storage for like offline scenario?
Well, one of the big ones is your page, right? So even using local storage, you still need to be able to load your original page to be able to do anything. So without service workers or something like app cache, someone's going to go to try and use your page and they're just going to hit that. In regards to assuming people are online, and you can and that is a legitimate thing you can try and do, is you could try and use service workers for caching API content, reducing server load, those types of things, which you could also deal with local storage. I would not at all recommend using it as a replacement for local storage, like as your your data store for your application. that's not what it's intended to be used for, and I think you're probably going to just hit a lot of headaches that just aren't worth the benefits. But for caching like your page assets, CSS, JavaScript, and the page itself to allow for that offline behavior, there's not really other answers out there that can give you that.
I know one thing that's kind of weird. I know last time we were talking about cores and stuff like that. Service Worker has some weird things in it that let you get around some of that stuff if you're retrieving assets from other websites. So it kind of does work to prevent you from accessing the content of the requests, but you can set it up so that your JavaScript can request it, and if it should have access to it, it will have access to the content. But because of that, you can actually also request that your JavaScript would not normally have access to, and then it just kind of funnels the request body around your code so it never sees it, but you can still load an image from someone else's site or make a JSON call that you wouldn't be able to make with just straight up XHR. But what you can do with service workers.
It seems like kind of like a really convenient abstract over the whole process of developing all of your own callbacks for each scenario of a failed request or whatever.
But you get some weird things too. So again, some of the stuff I skipped, but like if you're not incognito and you're running your Chrome extensions, every request of one of your Chrome extensions is going to pass through that fetch callback, and you might get all kinds of weird things breaking in ways you might start caching the requests that your Chrome extensions are doing. Yeah, it is very much like a general thing that you can use, but it can be very dangerous because of that as well.
Thanks. Is there a way to see it to tell if your user is online or offline and customize a service worker based on that?
So I experiment with that a bit. Like there is in the navigator, in like HTML5 has like navigator.connection. And then I think it's .offline. So there is an API that you can use to ask the browser whether it's online or offline. I didn't go too far down that path. There's a really interesting other dev idiosyncrasy where if you mark yourself as offline in Chrome, those fetch calls from the service worker still go through. So it's actually really hard to simulate offline when you're doing development of a service worker, short of actually just like killing the server. So I was thinking about experimenting around with that stuff, but I just didn't know how it was going to behave, what its definition of online versus offline. And I've had mixed results with that API in the past in terms of the browser's understanding of, because it can't differentiate between like you're connected to a wireless network that's not working versus, so by default, the way the stuff that I showed is cache first. So if you have it cached, it doesn't matter whether you have network or not, it's always going to serve it from the cache. But there's other things that you could do where you might do network first. So try and do something on the network, fall back to the cache. And again, you have all the control to do that. So there's definitely things that you could experiment around with that. Cool. Thank you.
Exchange.js is Edmonton's JavaScript meetup. Thanks to our sponsors, Jobber and Investopedia. Support the meetup and like and share this video, and stay informed by following us on Twitter and meetup.com. Links in the description. See you soon!